Okay, we are live. Hello, everybody who's deigned to join us today. I'm so excited. It's Bruce Eckel. Bruce, how are you?
I'm doing okay.
It's like my hero. I've talked at length about you over the many years. You have in one of your editions of Thinking in Java a letter from me from 25 plus years ago, and I peaked before I was even 20. That's the height of my success, was getting a letter reprinted in one of your books, kind sir. And that's okay. It's okay. I'm okay with that. If that's where I end up, I'm really happy. So I'm a big fan. Thank you for coming back on the show. We were in amazing Colorado just a few minutes ago, or I guess it was a year ago, at Dr. Subramaniam's Dev2 Next show. And I think that's the first time you were on the show. And
yes.
And then I left you alone for a year, which is a terrible idea because you have way too many interesting thoughts in the intervening time. So thanks for coming back. How you doing?
I'm muddling along.
I've been listening to you and our mutual buddy James Ward's amazing podcast, by the way. That's Happy Path Programming.
Yep.
Such a good run, such a good show, such a good experience, you know.
We enjoy it. We just it gives us an excuse to call up people and ask them questions.
Yes.
Yeah.
This is the hack. This one simple trick, you know, which is just get smart people to teach things to you. And so,
well, and I think also being interviewed, I find to be a different kind of stimulation that I normally get. Like a couple of weeks ago, there was this fellow from Poland who was interviewing me, and he asked me, what did he ask? He asked if I thought programming languages were converging onto the ultimate language. And immediately I said no, because what I have been seeing, and I think, maybe when I was younger, I kind of imagined that, maybe this is possible. But now I go, no, the more I look at it, the more I look at all these different architectural domains and how they're different. And sometimes you need a different language to support those different domains. And sometimes you don't. But anyway, it made me think. So
well, sure.
Yeah.
Well, master of none, master, what is it? What's the expression? You can't be good at everything, right?
What is it? Yeah.
You know what I'm saying?
Yeah, I know what you're saying, but I can't, for some reason, the phrase escapes me. Yeah.
It literally, jack of all trades is a master of none,
yes,
but oftentimes better than a master of one. What does that mean? What?
Yeah, that doesn't make, because it turns out that learning mastery is an important thing, because you learn what it is to master something. And once you do that, it becomes easier to dive into something else and understand it. So it's unfortunate that we teach people in school just to be the jack of all trades, or well, not even the jack, exposed to everything.
Yeah,
and,
just a taste.
And never master something. So yeah.
Is this what drives you? Is that why you have these incredible sort of dives into various topics and technologies? Is that do you strive to I don't think you're so presumptuous as to say you've ever mastered anything. Do you strive to learn as much as you can about a thing?
Well, I think I've always been seeking something, which might have been, maybe that's why I resonated so much with that question, is like, maybe I've always sought the idea that, oh yeah, there would be a perfect programming language. One of the things that started happening, I don't know, 10 or 15 years ago, I was a physics undergraduate, and at some point I realized that I didn't really understand what I was doing. And maybe 10 or 15 years ago, I began to understand what science is and realized, oh, I had no idea. And either they didn't think it was necessary to explain it, maybe it was too intuitive to them. We get this a lot in our field, like in functional programming, you get a lot of people who, or do you remember when people tried to describe monads as burritos?
Wait, what?
Yeah, this was 5-10 years ago. There was
How did I miss
there was
that? I love
there,
burritos and monads.
well, yeah, and they were going, oh, it's easy, a monad is like a burrito, and that just confused me more. And now that I have a grasp of it, I go, oh, all right, I can see why you would go there, but it doesn't help at all. It's a
I'm
totally useless analogy. But for a few years, it was like, oh yeah, monad, it's like a burrito, get it? And it's like nobody got it, but they couldn't. That kind of thing. We're really bad at
But Bruce,
explaining.
what does it mean? I'm you
Well,
10 years ago. I don't get it.
so I think the idea, one of the things we were doing on the conference where you interviewed me last year, on the way down, Bill and James and I came in the same.
Bill Fraser
Um,
and James Ward.
yes, and James Ward.
Co-authors.
We all came in the same car, and as we were coming down, James discovered, I think it was something notebook. It was an LLM. Um, and anyway, he fed the whole book into it, and he told it to make a podcast. And so we're driving along listening to this podcast, just having our minds blown, because they had, in no time at all, they had taken our book and turned it into like 8 minutes of these two people talking about it. And I was driving, so I wasn't fully tracking it. But a day or two later, while we were at the conference, I woke up and I thought, bento box. Oh, that's actually a much better analogy for a monad. So a bento box is that Japanese thing where they give you food and it's partitioned up into these little
Yeah.
pieces. And so that's kind of what a monad does, is it says, oh, one thing isn't enough. We need a bunch of things to come back from a function. And the original term came from Leibniz, the person who invented calculus at the same time Newton was inventing calculus.
Hey.
So, and Leibniz came up with this idea of a monad, and it simply means something that is indivisible. So, kind of the way they used to think of the atom. And so the
Right.
idea of the monad is we need more than just a return value from a function. We need a package of information, and we need all of that information, thus the indivisibility aspect of it. And if we have all that information, then we can do all this extra stuff. But if you just give us a simple return value, that's not enough information to do all this. Now, ultimately, you don't need to know that. And that was one of the problems that we have with the traditional explainers of functional programming, is that they wanted to get into the math and the details of the monads. And it's like, well, in our book, we said, we're not going to even mention the word. So nowhere in effect-oriented programming will you find a reference to the monad, and you won't find the signature of the return types of any of these functions, because we, first of all, decided that's way too confusing. And if we can get away with that, we're going to not show any of that stuff, because it just scares people away. It just seems too complicated.
Yeah. And we can prove that because I'm very confused. When I think of Well, let me see if I can hazard a guess. How, if I had to explain a monad from my very smooth brain, I would say it's what you just described, a indivisible object. Interesting. I hadn't thought about that. Maybe I'm coming at it from a different angle. When I think of it, I think of something that gives you information about the return value for its further use. So, like, you could return an optional of t. That tells you that you've got, might be a value, maybe not, but it's a t, but there's a, is it there or is it not, or you get an option, I guess is what they call it in other languages, or IO of t. You could do it's a description of IO, but there's an IO for something, or you could do a future, a completable future. It's a t, but it's asynchronous. It might come later. Is that?
Well, yes, those are all examples. What I would say, I would sum it up by saying it's a package of information that contains things like the return value and what do we need from the environment and what kind of errors might occur so that we're never throwing exceptions. And all of this is in this object that or type that comes back as a package. And so by using this, we are able to do much more with our composable operations. So the goal of an effect system is to allow you to easily compose operations.
Right.
And in order to do this, the price that you pay is that you have to pass more information around, which allows the effect management system to pay attention to, it could say, oh, are you composing these things correctly and successfully? So it's able to do type checking on that to allow you to do that. But the ultimate goal is this composition of operations.
Okay, and so the example with which I am familiar in my admittedly very JVM, and not even that, just Java, Kotlin, some Scala, but not to the point where I got effect-oriented programming ingrained. But in my world, I think about reactive programming. Is this, you're dealing with a T, but you're dealing with a T which I can then use to further transform it, right? And and of course the transformation is, the reason I don't have a T and the reason I have a wrapper of T, a thing that will give me a T, is because it has to run, and it has to run in the on an IO subsystem. I need bytes to be conducted somewhere, right? I need IO to happen. But when that happens is not up to me, right? I need the T, but all I can do is ask for it, and then the runtime will run it where it can and when it can. Is that sort of like what you're talking about?
Yes, that is an aspect of the composition that you're doing. So there's two, the factor that I didn't talk about, there is this extra information that we have to pass around, but then there is also the delayed execution of each of these operations. Yeah. And the way that we do that is, I mean, in some cases, like what you'll see in TypeScript is you use a tool called a thunk, which has been around. I first heard about it when I was on the C++ standards committee. I think Michael Tiemann was talking about it, the guy who started the GNU C++ compiler. And he mentioned this thing called a thunk. And it went into my head with a thunk. I had no idea what he was talking about. And it's actually very simple. It just says you have a function that takes no arguments and calls your operation. And so with the appropriate arguments and everything. So instead of directly calling your function and passing it the arguments, you say, all right, at some point in the future, call this thing with these arguments. And to do that, here is a function that takes no arguments, and all it does is contain this function call or this collection of function calls with
like
their
a runnable kind
what's
of?
that?
So is that like a runnable where you've captured the context, the lambda, the
yeah, it's been a while since I've looked at Java.
Well,
so
I mean, just imagine.
Yeah,
it's just a function that carries the other stuff, right?
Yeah, it's not a it's when you think about The weird thing is, oh, why do you do this? The actual structure is not, it's just, oh, here's a function, takes no arguments, and it runs some code. And the reason for that is so that then you can pass that to your effect system interpreter,
Right.
which decides when and how to call those things and say whether to call them in parallel or not, to, you know, various different things. It gives the effect system the flexibility to do all of the things that it needs to do, including manage concurrency.
Okay, so the concurrent. So when I talk about reactive, I'm really focusing on just one of many possible effects. I'm focusing on. Well, I suppose that reactive brings you I/O and concurrency. So maybe that's two. I don't know.
Yeah, so it's combining, I would say it's combining those operations.
Okay.
It's saying, but it allows you to do things like, okay, so I'm going to do some IO, I'm going to talk to another system, and because I'm going outside of the boundary of my system, I don't know what that other system is doing, is capable of. Is it even up? Is it busy? How long is it going to take to return result? And so I may need to put some other effects in between that do things like retries and fallbacks and stuff like that.
Yeah.
Now, in a normal programming environment, you have to go to a lot of work to put those things in. Whereas with an effect system, because we're passing this extra information around and we've got this interpreter that is deciding when to do things, with an effect system, you can just say, oh, I'm going to slide in the retry or the fallback or whatever it is, or and I can switch the order. I can easily, and because of that, we paid the price of having this extra information, putting it in this structure, which is a price. Because we paid that price, now doing what we actually want to do becomes almost effortless.
Right. Okay. So you're describing to the runtime what you want done. You're not telling it to do it. You're saying, here's what I want done, and then the execution itself is the runtime's concern. And because you're describing what you want done, you can stack operations. You're calling them effects, but in reactive you'd say operators.
Well, I saw this in the TypeScript effect library.
Okay.
And their description was an effect is an operation that encapsulates its own side effects, which is okay. But one of the problems with all of these explanations is that the people, us, who the technical people tend to get into the implementation details before they talk about the high level ideas. And so the implementation detail is, oh, it's encapsulating its own side effects. Well, that's not really what you're doing. What the important thing is, it's an operation that can be composed with other operations easily and moved around, you know, reorganized at will without the programmer having to do a bunch of extra code. And once you know that and you see that, you go, oh, this is why we're paying this extra complexity price to get into this game, is so that when we actually build our programs, we're able to say, okay, I want you to talk to the system, and if it doesn't answer, keep trying, and if that doesn't answer, here's a fallback to go to, and that, you know, whatever. We can, that's what we want to do. And what we as programmers have had to do in the past is all the fiddly little wiring, and we go, oh no, we want to switch this around. Oh, that's going to be a lot of work.
Because there's built up state that depends on things being in a certain order,
and I have to manage all of that stuff. Well, and another thing I realized not too long ago, because you remember Enterprise Java Beans?
Oh, by the way, what happened to that book, huh? What happened to that book? You were going to do a Thinking in Enterprise Java.
Yeah, I was. Well, and now in hindsight, I'm really glad I didn't, because I
Yeah,
had
me too.
no idea what I was talking about. I thought, oh, well, that should be, that's a big thing. I got sucked into the hype. I thought I was immune to hype, but I was not. I kept getting sucked into the various hypes.
Oh my God! If you're not immune, then who? Nobody is. It's just not possible.
Hmm.
You're one of the most self-reflecting and uh, willing to evolve people I've ever had the privilege of meeting, sir. So that says a lot. So okay. Yes, I do remember EJB. Thank you for that. It's not even. I don't have There's no alcohol near. I can't even drink to.
Yeah,
I
but
can't even pour something out.
you've thrown away all your EJB books at this point.
Yeah. I never had them.
If you ever had any. Well, and I tried to
Did
understand it, and
I
we
tell you?
we had a conference up here once, Martin Fowler and I, and
Yeah.
he was able to invite all these people, and he invited the head architect for EJB,
Yeah.
and he at one point said that something about an idea that escaped the ivory tower or something. It was still too conceptual, but I can look back on it now and go, oh, you were trying to do more or less the same thing. The idea was that you could say, all right, so these enterprise Java beans described what the system was supposed to do, and you would drop them into this container, and the container would magically do all this extra wiring up so that the
Right.
programmer didn't have to. That's the way it was supposed to work. It turned out
Oh,
that getting into that space was just, it was too early, but they spent, people invested so much money based on that promise.
are you about to tell me that that was an example of what could have been effects? Is that these declarative transactions, serialization,
Well,
security context, all that could have just been
I
effects?
think that's what they were trying to solve the same problem. And I didn't really get this idea until, yeah. And I told James this, and he goes, yeah, I think maybe I think maybe you're
Uh,
onto something. But I've been trying to figure out, how to describe effects. Or there's this thing called, well, I got this at the last Python conference, durable execution. That,
temporal.
yes.
Continuations as a passivated state. Yeah.
Well, but yes, but see, look, the natural tendency is to go, oh, it's about continuation, saving, whatever. And it's like, well, what problem are you actually trying to solve? And James showed us some code. We had book night last night we're working on a version of effect-oriented programming for the TypeScript effect library.
Nice.
And TypeScript is, anyway, James had just come from the Vercel conference,
Yep.
and they were talking about durable execution, and he was showing us some examples. And the examples, you look at that and you just go, wow, that is about the most straightforward way I could imagine solving these problems, because it uses the built-in ideas of async and await
Yeah.
to say, well, here's a point where you can freeze the state, and then once once it's time to continue, you unfreeze it, and then if your system shuts down or has to be transferred someplace or
Yeah.
whatever, it just does. It's like, oh, this is also kind of converging on what we're talking about here. How do we say what we're trying to do and let the system, and then the durable execution idea is, instead of doing it to the operating system, the operating system is moving to the cloud, and it handles the async and await stuff and the
Right.
freezing and unfreezing. But then the programmer only has to write, a few lines of code, and it all magically works. And the question came up, well, does this do effect systems do things that durable execution cannot? We don't know. Does durable execution scale to the same type of scaling that effect systems can scale to? What are the limitations? But even if it doesn't, if you can solve a ton of problems, this easily using these durable execution models,
Right.
that's pretty compelling. Maybe you'll hit play. Well, the Go language is a good example. It's
Mm-hmm.
the Go language is designed for particular niches, and but it doesn't scale to these other niches, but it solves, if all you're doing is writing uh, I've lost the word, microservices.
Sure.
That seems like what it was designed for. But and if you're if you're doing any kind of concurrency and it shuts down after a while automatically, if it ends and you don't have to worry about cleaning it up, yeah, sure, okay. But the problem with Go is when you start saying, oh, it's a universal language, it does everything. Well, it's
Oh,
not designed for that, and
right.
you're going to run into problems
You know,
if you go out of its scope. Yeah.
the durable executions. I saw this whole debate flare up. I think right after that, around, because
Yes.
it's using used workflow or something like that, right?
This string that it inserts
Right.
at the beginning of the function. Yes.
And that's there's some sort of magic preprocessor macro that turns on this, like, they intercept the async await stuff. In Java, we have the virtual threads, which is not the same thing, but the underpinnings of that are continuations, and that's actually an API you can get at directly if you wanted to. So you could actually, in Java, without having a separate compiler, do that kind of thing. And I've always kind of wanted to see that. I swear, Bruce, I swear on a stack of your books that I remember 20 plus years ago on java.net, the old source forge for the Java people. There was a project, and maybe it was the Hutchins/Jenkins guy that did it. There was somebody that had a continuation project that did the same thing. Basically, you could say step one, call method step one, call method step two, call method step three, and then it would passivate and then resume. And so even if the service failed in between step one and step two, it would just pick up. It would skip step one and go to step two. Same idea. And also because it was you're basically describing a directed graph, even though you were just writing regular Java code. Because it was doing that, you could also change the threading implicitly. You could say I want this to run on as many threads where there's not a direct dependency as possible, right? It was just, I don't remember the name of the project, and I've been looking for it for years. Java.net is gone and all that, but that whole world is super interesting to me. I've spent way too much time in workflow engines, right? So Temporal provides a kind of workflow engine,
Yes.
Which I love. Big fan of that. So
well, as far as that debate goes, we talked about that last night because James encountered it as well. And I mean, for us, because we've been sort of slowly figuring out TypeScript, which for some reason, there's a scene in Groundhog Day, the movie Groundhog Day,
right,
where Bill Murray goes into the shower and it's cold. And afterwards, he asks the landlady, he goes, is there any hot water? And she laughs and she goes, oh, well, there wouldn't be today. And this is our experience of TypeScript. It's like you go, oh, this is how it works. And it does, until this special case comes along. And then it's like, well, no, of course it wouldn't be consistent there. It's like there's so many special cases that you have to know if you're getting into the deeper levels of TypeScript. And it's it's
is it the same uncertainty that because the reason C++ is so painful is because it's C++ plus all of C, and the same thing for TypeScript is all of TypeScript plus JavaScript, which is a nightmare language.
This feels different than that. I mean, I because I started with C and then kind of initially figured out how C++ worked, and always understood what a lot of people don't understand about C++ is, yes, it's messy and complicated, but there's a reason, and the reason is always backwards compatibility with C, which at the time was really important because no, people were not used to learning multiple languages like we are now. At the time, oh, well, I know C, and dragging me out of C is going to be really hard. And so Stroop's approach of saying, well, C++ will be a superset of C, it will be an improvement over it, and which that TypeScript follows that to some degree. But because of that, C++ had to be extra convoluted. And if I don't think it would be successful now if it came out, because people would go, oh, if I want that kind of low-level control, I'll just use Rust, and if I want to use a higher level language, I'll use something else. But it's you're still paying for the backwards compatibility of C++. So so TypeScript is kind of like that. In that Anders was trying to do the same thing, but there had been other languages where they said, well, let's put a superset or some sort of improved language over JavaScript because of the horrors of JavaScript, and he had to. Yeah, so I mean, maybe your analogy with C++ is not so bad because of the backwards compatibility with JavaScript and that transparency. But then there are other things which C++ wasn't. Like last night we ran into the as keyword.
Oh boy.
And it's like, well, yes, it's sort of like a cast, and sometimes it's transparent, and other times it does something weird. And we ran into something where it was like, okay, it seems like we shouldn't need this cast here, but if we take it out, the compiler barfs.
All hell breaks loose.
Yeah, and then, but in another case, we could take it out and it was just fine. Almost identical case. And we just like, okay, we have no understanding of this. I think for as long as you're not getting too deep into it, I think people can have a lot of success. But once you start digging down into some of the more complexities of the language, it becomes just a kind of a nightmare of special cases, which I would say is worse than my experience of C++ was. I could always trace this back. I could say, oh, there's some rationality to this. Whereas it feels like with TypeScript, there are things that just work and then suddenly they stop working and you're supposed to know why you crossed that line. And I don't know anyone, anyway, it's
I agree. I think a lot of it, I mean, just JavaScript itself is just riddled with all these special cases. Like you do return, new line, curly bracket in a function. What happens to the curly bracket? You've created an anonymous inner object, but you've returned. Where's that object gone? I don't know.
Oh, you mean in terms of like, oh, you've allocated storage and you've returned this thing.
Well, you're not returning the object. You're returning. It's actually return. It adds a special case semicolon there. So return enter is the same as return semicolon. But then after the semicolon, I did a curly bracket. Where's that curly bracket gone? It's in purgatory. It doesn't exist.
Or right. It's created an object. Is it on the local stack? Is it?
I don't know.
We don't know.
Magic.
Yeah. And then you can put a string at the beginning of the function body, and
which is nice in Python for documentation. For everything else, I do not approve.
That's the doc string. I think people have used it in the past, but I don't think anyone does that now. They use decorators for Python.
Yeah. Well, that's so
macro tool.
I think when you say they preserve backwards compatibility. Interestingly, I think even though C literally defines the ABI by which everything else now links, I think what you were talking about there is source code compatibility, right? C++ maintained, you could take a valid C program and paste it into a C++ code page. But if they had said, quite like Kotlin did for Java, if they had said, we will maintain the ABI, we'll support interoperability through the ABI, but we do not support pasting in Java source code into a Kotlin program, I think that would have been actually a really good thing. Like you would have got in JavaScript and TypeScript, it's not so easy to do because there is no binary JavaScript. There's no link. There's no library of sorts. They all get interpreted in the same compiler in the same runtime.
It is Yeah, it's we're having an interesting experience trying to sort this language out.
Well, it's good
And
getting your
I
hair
don't
hands
feel
on.
like I'm ever going to get, I mean, from what I've seen so far, I don't feel like I'm ever going to get that depth of knowledge that I had, say, with C++, um, when I was working on that.
I think that's okay, though. I think at some point you got to be able to say, I can
It's going to
shed
have to
this
be.
knowledge. Yeah, it has to be enough. You can't.
Because I don't, I also, I don't think any of us, we run into things like this, and it's more like, okay, I don't want to use up my brain space on these weird special cases.
Right.
So we're kind of the point where we're just going, all right, can we get through this to the point where we can, figure this stuff out? And
Right.
probably can, but sometimes there are these special cases that just flummox us.
All the
And
time for me.
yeah.
You mentioned Go a minute ago, and
Mhm.
you mentioned Go, and Go has because you and I were touching on this before the show, and it really kind of stuck with me. Go doesn't. It has structs. It doesn't have objects as such, right?
Mhm.
And I think you said something to the effect of like you weren't particularly persuaded that that the full-on object-oriented experience that we know today has proven to be all that useful. And then I think about Go, and you're right. Go doesn't have
No inheritance.
no inheritance. It has types.
Yes, has types, but no inheritance. And Rust, Rust is probably a better example of this. It has a much more robust type system,
Yeah.
but it also does not include inheritance. Basically says, if you need to do this, use composition, which
Mhm.
is in the introduction to the design patterns book. That was one of the famous things they said: prefer composition to inheritance.
Yeah.
And yes, this has been creeping up on me for several years. And at the same conference where we did the podcast, I ran into Dave Thomas. We
Oh,
were talking.
which
Yeah.
one? The Ruby one, the Wendy's founder, or the one in Australia who did the small talk stuff? Pickaxe book,
The
or
well, they did.
not in Australia, Canada. Sorry,
Yeah.
there's three of them.
Well, it's all confusing because he lives in Texas now.
So,
The pragmatic programmer.
yeah.
Dave
Okay, pickaxe
Thomas.
book guy, the
So
Ruby
he
one.
was there, and we got into this conversation, and he said somehow we started talking about object-oriented programming and how long both of us had spent writing and teaching about it and everything, which I haven't done for a while now. But I think the way he put it is he said, so have you ever really found a situation where you naturally went to the is a relationship? Oh, this thing has an is a relationship. Or the way that I've started thinking about it is, okay, types are really useful, and that's kind of at the core of object-oriented programming.
Yeah.
But families of types, inheritance in general, is that really that useful? And all the problems that people have had with its deep inheritance hierarchies, that kind of thing. And people have started talking. They've talked about it as an abject failure. And I initially kind of came at it with that idea. But then I started thinking about it and go, well, it's not really a failure. For one thing, at the core is types.
Mm-hmm.
And that is, I would say, useful almost everywhere.
Yeah.
And and the real problem is inheritance. And even then, there are some situations where that's a convenient thing. But the way languages like Go and Rust, and probably maybe most future languages at this point, look at it is saying, well, if you really know how to, if you really need that, you can wire that into your you can wire it in yourself. In fact, I remember encountering people when I was initially proselytizing about object-oriented programming, and you'd encounter some people that go, "Oh, well, we've been doing that in C," which, how could you do that without a virtual function? I didn't understand it at the time. And eventually you see, oh yeah, you can do that, but it's so much harder and you need to use it everywhere. and the need to use it everywhere part is where I've really started seeing, and Dave Thomas and probably a bunch of other people started going, yeah, you don't really use it enough to justify hardwiring it into the language.
Yeah.
And the motivation of the people who initially used it, if you go back and trace it, the original implementation was in a language called Simula, and
Yeah.
it was, as the name implied, for simulation. And people who got into simulation were trying to solve this one architectural problem,
Yeah.
and they felt like, oh, if we have this thing that does this dynamic binding, then we can have all these families of simulation objects, and we can just say, you simulate yourself however you do it. And it's like,
Right.
cool, but that isn't the vast majority of things. But the folks who were, I mean, like Strustrup had experience, that he came from that, and even simulation, because you go, well, video games are,
Yeah.
they're massive simulations. Well, it turns out that dynamic binding doesn't really scale to that level. And so video game, they use a different model for that doesn't have the overhead of dynamic binding. They use a different approach, which I can't remember the name of right now.
And we've introduced things like in Java, we release, you've got union types, you've got exhaustive types, type checking, you've got all these things that we've added to the language to effectively seal the hierarchy, because it isn't efficient otherwise. If you have infinite possible implementations on the class path and you have the whole world, then in theory every method has to reconcile that fact, right? Every method invocation has to reconcile that fact. Now you've got sealed hierarchies, so the compiler can say, hey, the world of implementations are known at compile time. There's only 4, and it can only be one of these 4, and it's a lot faster. But we're now adding things to the language to compensate for the aforementioned scalability limitations of virtual method dispatch.
Yes. And I, for the longest time, I just thought, oh, well, the most important thing is the abstraction, the programmer productivity, that kind of thing. And it took me a while before I realized, well, ultimately, it is performance. It does come down to performance, because if the machine can do it, if the human can do it faster than the machine, we're going to use a human. That's always been kind of the scale. And so even though there are places like, Python is a good example. It's like it optimizes the programmer's time. So, we can solve this problem really quickly. Now, does the problem execute? I mean, does the solution execute really fast? Sometimes it does. There are ways to make it execute faster, et cetera. But initially, being able to, rapidly prototype is what you get. And for, who knows, maybe 80% of problems, the solution that you come up with is perfectly fine.
Yeah.
And there are ways to perform the optimization, which take more time and effort. But, it's kind of but ultimately the reason that we're using the computer is that we can create things that do work faster than we can, a lot faster than we can.
Yeah.
And so performance is important.
And when you mentioned Python, that's a great example. The scientific and data processing community will reach for SciPy and NumPy, which are C extensions. So, works. Python itself isn't the fastest horse in the race, but it works fine because you can call out. And then, speaking of effects, you've got async IO, right? So one of the reasons I'm going to be bottlenecked is because I have things blocking on these IO operations. But now I can say to the runtime, hey, figure this out, sequence things so that I'm not ever sitting there doing nothing while IO is happening, right? And so that gives you better scalability. And again, it's a very sort of, Python is letting you just say, I want this to run. Don't wait for this IO to happen. It's a declarative kind of almost like an effect, right? And you get good results there if you can just take advantage of these little escape hatches.
Yes. Ultimately, an effect system is trying to get when it's dealing with concurrency issues, which
Yeah,
I include both async and parallel. The
sure.
idea of the effect system is trying to abstract far enough away that you can simply say either it can, ideally it can go, oh, I can run this in parallel. I have enough information that comes back in this package of information that I can see that I can run this thing in parallel with that thing. And you might not even have to intervene with that. You might not even have to say that. It seems like that's kind of where we would love to get to,
Right.
where the programmer doesn't have to go, oh, I need to do these things asynchronously or in parallel. And if that, that's what you get with that information package is you're handing the effect system the ability to look at these things and go, oh, I can run this in parallel or I can run these things asynchronously without us having to get, delve down into the morass that is
Oh.
concurrency.
So when you talk about, I have a lot of code that I work on and that I look at, and I'm really struggling to think about where I have deep hierarchies, more than one layer, and even there, and actually one of the few places we might have used hierarchies before is if you follow this notion that each class, each thing should do one thing and one thing only, a single
Mm-hmm.
responsibility principle, right? Which is not a object-oriented concern; it's just a programming concern. When if you follow that, then you might say, well, maybe I want this to do the thing that my business service does, but then I want, and then I create a subclass, and that subclass handles wrapping the superclass with transactions or whatever, or I'm adding layering these extra concerns, sort of like that EJB case you mentioned earlier, right? I want to layer on all these concerns, but even there are ways to add these declarative concerns now that don't require you to use hierarchies. Quite the
And
contrary.
are more
Yeah,
elegant and easier to understand. And
yeah,
yes, the deep hierarchies started. This was how people. Gosh, I remember one of the first ones was Borland and Microsoft were both creating user interface libraries
right.
using these deep hierarchies, and I never really figured out how to use them, and I think they eventually kind of fell away because maybe nobody else could either. But the thing you end up with is if you inherit from one of these things, you would often get forced to override a bunch of methods that you didn't understand. It was saying, well, you got to do this because of our whole mechanism that we've built in here that is more complicated than you can or want to understand. So
Right.
now you've got to provide all of these pieces of code. And it was massively confusing. And you're
Yeah.
going, it seems like I should be able to just do this thing that I want to do. And so I think a lot of these things have just fallen away, and we haven't realized that ultimately we never really needed to have this kind of dynamic binding built into our programming languages. And who knows, maybe there are some programming languages where that's still for the problem domain that programming language is designed to
Right.
solve, that is essential. Maybe there are, but I think it's something that we have gone through a long fad
Hmm.
of saying, "Oh, we found the solution. It's the universal truth is object-oriented programming," and it was not. And even if you see what is the most successful object-oriented language there was before, it got wired into C++, it was Smalltalk,
Hmm.
which was
Different message passing.
so dynamic.
Yeah.
It was like everything was dynamic. You just go, oh, here's a thing. I can take it and I can add something onto it, and now it does a new thing. And you didn't, because it was not a statically compiled language, you weren't
Right.
saddled with all of these extra, oh, well, for the thing to compile, you got to override all of these other things that you don't understand, don't know why. So going from this dynamic language that seemed to work really well for the kinds of problems that were solved with it, to a statically compiled language. I mean, think about the Liskov substitution principle.
Yeah.
It basically says that you got to know everything in the base class because
Yeah.
it's statically compiled in order to get it to compile. It's like, boy, that sure doesn't feel like what made Smalltalk so compelling.
Right.
And yet, people say, oh, well, you got to follow the Liskov substitution principle. And I'm not really sure that it's appropriate at all.
I don't know. I mean, Liskov, does that apply? It doesn't apply really. We've got a couple of escape hatches now, right? We've got, I mean, if you don't have implementation, then you can just work with interfaces, and that's just a type, which we talked about earlier. That's useful. And to the extent, I think the best compromise has been you've got these default methods, like in interfaces in Java now, or in Kotlin, you've got the ability to have these default behaviors. And that
that
gets
are
you
automatically built when you create your struct. Yeah,
right.
but see, that to me, that's more of a type
Yeah,
and not an OOP object.
it quacks like a duck,
Yes.
and you can even get reusable behavior,
Hmm.
but you're not straddled with, the inheritance triangle diamond.
Well, yeah, multiple inheritance. There's another thing where it's like, oh my gosh, what a messy thing to have to deal with. And why were we doing it? Well, because if we have inheritance, we need to support all different kinds of inheritance. And I struggled with that and figured it out and explained it, even though I was just explaining the mechanism
Right.
of multiple inheritance, not why would you use this, not the design
Yeah.
aspect of it.
I mean,
And
but the other thing is that multiple. I mean, it's not okay. As with all things, it's contextual, isn't it? Multiple inheritance is scary from C++, and yet in Python, it's not great, but it's still not nearly so scary. And I think part of it is because of memory management, right? It becomes safer and more. I mean, Java doesn't have multiple inheritance, right? We have you can still get the diamond problem because of these default methods, that kind of stuff. But it's not really built in. Whereas in Python, I don't know, it's never felt very scary for me. It just seems
no, they worked around it. It took a while to figure. Oh, well, I can remember they added some kind of mechanism that you have to work through. But the thing to ask is, oh, first of all, do I need a family of types? And then, do my types need to belong to more than one family? What kind of problem are you trying to solve?
Yeah.
And when you look at functional programming, what it does is it still has, like, an object has a constructor and it might have ways to copy itself, and it has some basic functionality,
Yeah.
like, which now a lot of languages have adopted. Java has its records, Python has its data classes,
Right.
Scala has that, Kotlin has things like that, where it creates this type that does all the things that the type needs to do. But then when you start adding methods that do other things on that, is that appropriate? Maybe it is sometimes.
Yeah.
Or does it make more sense to have a separate function that just acts on, especially if you're dealing with immutable objects? Does it make more sense to just have a function that acts on it and creates a new object of that type or of a different type? All these questions.
I did while we were talking, because I was scratching my head here. I know it's better, but I forgot why, and I don't understand how. Apparently, Python has the C3 linearization algorithm.
Yes,
that ensures each class is called only once in the correct order, which sounds so simple, but I'm sure there's
magic underneath.
Magic going on there that makes it work. But it does work.
Figure it out. And then, somebody put a lot of work in. Python's a weird one because it can adapt to so many different programming styles.
Sure.
And so it's it's like it's not forcing you to use inheritance. Problem with Java is that they went all in and they
Yeah,
go, okay, everything's going to be an object, and you're going to use, it's they 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 overcommitted
totally.
to that.
Although mercifully, thanks to Kotlin and Scala and others
Yes.
allowing more hybrid approach, just now Java 25, the one that just came out a few months ago, now supports, you can start a program in Java without a single class in sight. You can have just void main and then do something, not public
You
static,
know why?
not schema.
You know what's annoying about that is you're celebrating this thing that should have been there in day one.
Agreed. But
When
better late than never, even if it's 30 years late.
3 years, one of the rules that I had when I wrote Thinking in Java was I'm not going to put up with this hand waving over public static void main, whatever, all of that stuff that the programmer and so many people were just going, oh well, don't worry about that. And I go,
Yeah.
I don't want to do something where people are confused about they have to understand all the terms to make hello world work. And okay, great, finally they listened after 30 years. I don't have any respect for that. I don't know.
Oh,
I mean, great, fine. You did something that should have been version 1.1. They should have done that. But no, I don't know. I'm not.
they
I mean,
took.
the thing is, I was never a fan of Java. I think the reason that Thinking of Java was successful was because I went at it with the point of the goal of showing where the flaws were.
Sure.
And that was useful for programmers because then they weren't going, oh, why this should work? Why doesn't it work? And so I drilled down and showed where all the flaws were. And that's what I was trying to do. But
Always.
from the beginning, I was not, I've never been a fan of the language.
I know.
I've always found it very annoying and a lot of the things around it. Yeah, but yeah, whatever. Anyway, I mean, if you're using Java, if that's what you have to use, then at least they're improving it. But there's a lot of people who still can't use modern versions of Java because it's too big of a change.
And to them, I say, Kotlin, just do that. You can still interoperate with the JVM, which is a wonderful place to be.
Exactly.
And you get a really nice modern syntax. And
but of course, for a company that won't move forward to a more recent version of Java, converting to Kotlin is, well, I understand at least you can use an earlier version of the JVM with a better language, but it's still going to be a big ask for a company that's saying, well, why should we change to a newer version? Yeah,
I think a lot of it, from when I talk to people, it's not that the programmers are scared; it's that the operations people are
and management
in Kotlin, whereas
the programmers are frustrated often because they can't use new and better things, and they're stuck in a system that says, well, no, it's too scary to improve anything. So yeah, but that's a different topic. That's the topic of management and hierarchies and business and all of the delusions in that world that programmers have to deal with.
Right. And I think you talked about earlier, is there going to be, we started at the top of the show, we talked about, is there going to be, what was that question? Is there going to be like one true language or whatever?
Oh, that this fellow from Poland, and I've been there speaking at their conference years ago, that he asked me, he goes, do you think we're converging on like the ultimate programming language or something? And I did not hesitate. I just said, oh no. Nope. But at one time in my life earlier, I probably would have thought, oh yeah, it must be possible to create an ultimate programming language. But now I would say, no, languages often solve different problems. I mean, look at TypeScript. The original goal was to solve the UI problem, but of course, then you had this weird other problem, which was, oh, we want to be able to write the back end with the same language that we write the front end. And we accidentally learned this terrible language for the front end. And now we want to use it on the back end. And it's like, oh, well this could have gone better.
is that the ineluctable sort of slide for all? I mean, think about it. So not all languages can do all things perfectly. No way, right? But just in the conversation we've had today, you've got Python adding type hints. Heck, even Python added object orientation after years of not having anything of the sort. It was, it didn't have objects at all in the very first versions, right? And then you've got
It
types.
had it pretty early, so I don't remember when it
Yeah.
was fully embraced. But
And then,
yeah,
I mean, Java adding some function, not really, but some functional idioms in Java 8, and now it's adding, you can write a program in Java today without knowing about a class. You need to know about objects and instances and types, but you don't have to know what the class keyword does if you want to for your program in Java today.
languages evolve. Yes,
Yeah,
that's what we're seeing.
They're
And
converging, but they're not going to be the one true, right?
They evolve, but then the problem with languages is they carry backwards compatibility baggage with them. And so I think that's why you can evolve your language to a certain point,
right.
but then at some point you go, there's too much baggage for us to be able to do this new thing. There are languages that are being written now that are integrating effect systems as core language features rather than add-on libraries.
Yeah, I like that.
Yeah, and hopefully that'll make it easier. It's hard to say because like the durable execution stuff, if that really scales, it might be hard to make the case for effect systems because of the complexity. But the durable, I mean, until I know more about it, the durable execution, it may just be handling a subset of the problem. The effect library has a library to do durable execution. So that sort of suggests that durable execution is a subset of effect systems. And so we still may benefit a lot by having effect systems, but I'm just speaking with very little knowledge at this point.
I think you're right. I think both can be true. I think durable execution and things like it will scale, but also technically they are just subset. It's one of a crayon box full of different effects that could be, you can insulate your program from the complexities of those effects.
That might be true, but if durable execution handles 80 or 90% of the use cases, the simplicity that I saw with these examples, it's like, boy, that's going to be hard to for the other 10 or 20%. I'm again just guessing here. It could be.
Right.
I mean, even if it solves half the cases, that's compelling because you can do a lot with very simple code, and it's like, that's definitely worth looking into. And who knows, we may need to be exploring that more in some way or another, because it makes programmers way more efficient, and that's what we want.
I surely do, yeah. And now that the runtime, it used to be that you wrote the code and it ran on the machine. Which one? Well, the one. We've got the mainframe. There's no other machine. It's the only one that we care about, and that's all. And then eventually you get the personal computer, but even there, it's 90% Windows for decades, and okay, so it's the machine. And which chip is it? It's definitely not Intel, right? It is Intel. It's going to be an Intel, and that hasn't changed since the 80s. It's gotten more, but x86 in the 80s still runs today. It's just you don't have all these new chip instructions. Well, now, my goodness, you've got the interpreter, you've got multiple languages, operating systems, runtimes. Am I in the cloud? Am I running on Lambda as a function that gets invoked and then dismissed?
Layers of abstractions, yeah.
Well, yeah, and so to the effect that all these concerns are like changing underneath my programming, having effects that allow me to opt in to that, or to handle that sort of independent, like I don't know, that seems useful.
Well, it's a higher, and Andrew Koenig told me once, how did he put it? He said, all problems can be solved with another layer of abstraction. Right. And that's what we're talking about. Of course, sometimes the abstraction layers come with costs, and sometimes the costs are not, not reasonable for the problem that you're trying to solve. But but still, and an effect system is, yeah, definitely we're moving up to another layer of abstraction. And I
Mhm.
think the problems that we run into are usually some manner of scaling problem. Because as you said, initially we had these mainframes and you wrote assembly code to run on that
Right.
mainframe. And it was not portable to anything but others of those things. And then we started moving up so that we had higher level programming languages, and we
Right.
don't, we can easily or relatively easily target it to different languages. I mean, to different machines, different operating systems, etc.
Yeah.
And with an effect system, you're able to say, oh, we just want to say what we're doing. We want to say, what do we need to do this? What kind of problems might occur when we do
Right.
this, etc., which is definitely a layer of abstraction higher, but that allows us to do more with less fiddling about. And
Did this
ultimately, that's what we want to do.
did we take a really circumlocuitous route to 4GL? Is this kind of like 3.5? Or do we say what we want to do, but we surround it with these effects that where we say what we want for the stuff we don't care about? Like we need to run on the IO subsystem. So run when you can. But I here's my business logic, right?
Yeah, I think, I mean, this is a relatively recent realization for me, but it does seem like there's a consistency to the kinds of problems that we've been trying to solve
Yeah.
all this time. And it is this raise the layer of abstraction so that we can say what and not how.
Yeah. Right. And
And this does seem to be closer to it. The struggle that I had was just initially dealing with the functional programming clan, who their favorite thing seemed to be to get as complicated and into the weeds as quickly as they could. And so it would just drive away so many people. I mean, we've had the whole problem with the Scala community and its unfriendliness,
oh
and
yeah.
yeah, all of those things. But eventually we get to this point where we can say, oh, here's the problem we're trying to solve with this thing, which has just become my mantra. Why are we doing this? What problem
Right.
are you trying to solve? And if you keep asking that, eventually you can usually get some valuable answers. But for some reason this one has been particularly hard. Or I don't know, I guess if we go back to object-oriented programming, we didn't really ask that question hard enough. What
Yeah.
problem were we trying to solve? Why do we need families of types? Um,
Yeah.
and well, and I didn't even know. I still remember when Strustrup said during one of the committee meetings, or at some point saying, "Oh, and you can create user-defined types." And for some reason, that was like, "Oh, that sounds very interesting."
That
But
is
then
nice.
I got totally lost into the whole inheritance and dynamic, and I didn't.
Uh,
For so long, I thought polymorphism meant dynamic binding, and
yeah.
then sometime in the last 5-10 years, I went into a rabbit hole trying to figure it out. And it was like, no, polymorphism means you can use different types in a function. You can have one function that handles different types. And dynamic binding is one way to achieve that. But function overloading also achieves that.
Yeah.
There's numerous different ways to achieve this idea of polymorphism. And do you need, I mean, like even that, like, well, why is that useful? Well, the goal is to reduce the amount of code that you're writing. And when you
Yeah.
write a piece of code and you debug it, it becomes something that you can use universally. And now we're talking more about what functional programming does.
Right. Where you extract
Yes.
these
Yeah,
atoms.
and you're saying, well, let's have this function that works with all of these things. And then maybe when you generate your types, uh, they ideally automatically adapt to some functions, or maybe with a tweak here and there, they can adapt to these other functions. But instead of putting the methods in, putting all the methods inside of this object, instead, well, maybe we need to take the methods out and
Yeah.
have them work kind of more independently. That's maybe the biggest shift in functional programming.
Is it you mentioned Scala, and I think it was trying to do two interesting things. One of which is to say, here's this language which vaguely looks like Java, but it's an object-oriented language. It has a different syntax slightly, and also we have this operator overloading, so we can do these really funky things with operator overloads for pipes and all that kind of stuff. But also here's functional programming, so you're getting hit with just a lot, right? Whereas functional programming with Lisp, where you have none of that object-oriented baggage, is actually quite timid, and it's quite pleasant and approachable. But of course, you don't have types at all. You've just got, it's Lisp. You've got one thing, and it just does it really well. It's lists. Would Scala have, if we had a strongly typed Lisp, would we have gotten further?
Well, the way I have come to think about Scala is as an experimental language. It was basically it came from a research institution, and it was like, well, let's try these different experimental language features and see what happens. And your example of operator overloading is great, because the exercise was, oh, what happens if you can make up your own operators, and they can be whatever characters you want to mash together, and you got
Right.
and you got these operators. And what we discovered was that for the human brain, that was just overwhelmingly complex.
Right.
And what you really want is basically what Python did. It said, here's a standard set of operators that you can overload. You can't make up your own. And
Right.
that needed that constraint. And this
Right.
was unconstrained operator overloading. Scala showed that that's a bad idea. And people don't really do that in Scala
Right.
anymore. And then there were other different kinds of things, which I can't remember. There was a lot of different things that they tried out.
Yeah.
And from that experiment, a lot of other languages benefited. I mean, I'd say Kotlin benefited hugely. Python did.
Java did.
Yeah. Java, I would say, because people started saying we want these features, and then eventually they were going, all right, well, and Brian gets all credit to him for taking this, I don't know, monstrosity, and being able to add these things in and make them work.
Right.
Backwards, I mean, that is an astounding accomplishment.
Turning the Titanic.
What's that?
Turning the Titanic with millions and millions of passengers aboard.
Yes, and so I mean, I would not want that job, just because I would find it incredibly depressing to be able to to try and do that. So amazing. I mean, takes the kind of smarts that he has to be able to accomplish that. However, it's a language that I don't want to have anything to do with anymore. So, and it's been that way for a while. It just despite, yes, I could make a lot of money if I just kept writing Java books, but I can't do it anymore. I don't want to.
Did you see Brian Getz's more recent, he did a Java language summit video where he talked about value types and all the sort of knock-on effects, not to overload that word in this particular conversation, but the knock-on benefits, that's a better word perhaps.
He's talking about immutability, you mean?
Well, value types so you get value types which are, better for cache line, CPU cache line alignment, and they're much more efficient. Sure. But also it gives you the ability to add new primitives to the language, new primitive types, which then raises questions around nullability. So you have to add nullability to the language. And that, of course, brings up questions of, well, if I have a new primitive, like a big integer, I can treat big integer like a primitive, then why can't I add two big integers using operators? So now you have to add operator overloading. But of course, he was very clear about, he said, we're not going to allow unconstrained operator overloading, only the sensible numeric operators that you learn about in algebra.
We learned that lesson from Scala. And see, the thing is, when you look at operator overloading in C++, very attractive and everything, but because C++ didn't have a garbage collector, you
Mm.
had to deal with, oh, A
Oh,
plus B creates something which is floating out there somewhere or whatever. You had to deal with all of that stuff. When you
yeah,
add a garbage collector to operator overloading, now it becomes relatively easy because the garbage collector takes care of that complexity.
yeah,
So, but for a while, people would go, "Oh no, operator overloading," and that's why it didn't, show up in Java, because initially everybody knew operator overloading was too complicated from C++,
right.
even though having a garbage collector made it easy. So, I mean, it's just, I don't know. I think I'm to the point where I'm sort of kind of moving up out of, even though it's taken me forever, like it takes everything. I have learned enough programming languages that I'm starting to kind of not be interested in learning the details. And maybe this is where um, TypeScript is helping, is
Yeah,
like, okay, maybe I'm not interested in diving into yet another programming language and learning its details. Maybe I'm more interested in some of the issues we've been talking about here.
yeah,
Just the higher level ideas, like, uh, I don't know if I want to call it architectural, but maybe design issues, like
yeah,
just the idea that there are different problem domains. That's why we don't a universal language maybe doesn't make sense, because we have different problem domains. If you look at Erlang, for
yeah,
example, look
yeah,
at its problem domain and how it solves it. This idea that, oh, well, if you have tons of these little tasks running, if one fails, you log it and you put it back up. And you think about that and you go, wow, this is a different way of thinking about things,
kind of like
because,
durable execution.
well, it is. It's like
Yeah,
durable execution, but look at also the way it looks at failure. It goes, failure is a data point, but
mhm,
everything else about this task was working okay. Only
sure.
this situation where it failed, and so we can put it back up and it can continue to work okay. Our
Yeah,
whole system keeps working okay, except when it runs into that problem, which we log, and eventually somebody comes along and goes, "Oh, let's fix this."
yeah,
But your system, the idea that, oh, here's how we keep our system running. So here's a problem domain where that's the most important thing. And that is a different architecture than, I don't
sure.
know,
Whatever.
maybe a lot of the problems that say Python solves or Java solves or whatever. And so that one idea that there are different problem domains and there are different architectures and even
Right.
programming languages that are appropriate, that idea is something that we should be teaching in college, I think.
I agree.
Yeah.
That's the Erlang supervisor hierarchies, right? The OTP stuff, which I always thought was like the bee's knees, because that is
Hmm.
9 nines of availability for your Erlang actor
Hmm.
stuff. I remember thinking
Isn't this
like
interesting? But then
amazing.
and then initially you go, well, we should solve all problems with this system. And now you've fallen down that rabbit hole
Oh yeah,
of, oh, yeah, the universal solution, and realizing that, wow, there isn't, even though, so I was talking about physics and how I didn't understand it,
yeah.
and um, and recently starting to understand it and realizing that, oh, what science is science models causality.
Science models the thing that results in a change in the universe.
Um,
Am I misunderstanding?
Well, no, just what we're looking for is causal relationships. We're going,
Okay,
a thing happened and this result happened, or this
right,
other thing happened. And science says, oh, well, let's look at that and see if we can establish a causal relationship between those two. And
sure.
ultimately, if you look at Bayes' theorem, so what's weird about it is you think, oh, we're talking about laws. They don't actually call things laws anymore in science, because that was kind of arrogant. They're just models, and a
Right.
model it fits the existing data, and it's predictive. It produces, and so that's all it does. It's not a truth. It's just something that works. It gives you useful data. And if the model stops giving you useful data, you have to go in and tweak it. But it isn't the thing that I didn't understand. I thought we were dealing with truth here. And so that was just like, wow, if I'd have known that, I'd been a much better physicist. But when we come around to computer science, realizing that, there isn't a universal language, there isn't a universal architecture, that you
Right.
have to look at these problem domains and understand them, and, evaluate them. It if you solve the same problem over and over again, if you go, oh, it's a web system, we need a database, we need a UI, a few other
Okay.
wiring details, you solve that problem over and over again, and you start to see the world in those terms.
Yeah.
It's called Conway's, it's a variation of Conway's law,
Right.
which says that your architecture looks like the business that you are in.
That you
You know,
traffic in. Yeah.
yeah, it's these are all these limitations that the human brain has. And most, the number of things that we can hold in our brain is too small for so many of the problems that we're trying to solve.
I see.
Yeah,
Okay.
it's, and it's not, they used to think it was 7 plus or minus 2, but they're finding, no, it's actually much smaller than that. Might be 3 or 4 things you can
Wow.
hold in your head. And you think about that, and I mean, for example, somebody who is running a company, why do they make so many terrible decisions? Well, they have a few things that are important to them, and they see all of these decisions through that lens.
Right.
And we do too when we're solving computer problems.
Sure.
We go, well, I know, first of all, I know this language. I know object-oriented programming, so I need to put everything into a hierarchy. And we just, we get stuck in those grooves, in those modes. And to be able to step back and go, well, let's find out what problem we're actually solving here, and let's keep asking that question until we're actually clear on it, and then we can say, oh, what's a good way to solve it, and then maybe we can solve it way faster and way more uh, elegantly, in a way that adapts to the future needs of the organization.
Yeah. I think you just people put things in they look at problems through their prisms,
Mm-hmm.
and that's their prism, but it's not necessarily the best prism by which to examine something. And I sort of wonder. You spoke to the idea of a CEO running a company. I wonder if there would be, if it were normal for all companies to have a board, even the private ones. Would we make better decisions instead of having one CEO? What if there's a team of CEOs? That
Right.
have diverse perspectives.
Yeah. Somebody just brought up the idea of, I don't know, earlier civilizations, sometimes they would have more than one, I don't know, king or whatever.
Yeah.
And, there would be the king that you would have, or well, oh no, this person was talking about, this was Joe talking about, he's going, okay, so we were in this situation, we were camping,
Yeah.
and suddenly we were being caught in a hailstorm. And my friend said, he went into command mode and he said, okay, first, here's how we put up the tent. Do this, do this, do this. And Joe just went along with it. He was going, yeah, we clearly need to get shelter set up.
Sure.
And so, but so many companies run in that mode all the time when it's not appropriate, and they just exhaust everybody, and they make decisions that don't fit for the long-term thinking. They're always thinking in short term. Okay, how do we maximize quarterly
shareholder value,
or whatever it is? And so they make these knee-jerk decisions, and what you actually need is somebody that's more of a long-term thinker for those kinds of things. And then if you get into a crisis, then you have a different person. Or, I mean, my hope is that we will have a lot of AI assistants for making these kinds of decisions that go far beyond what the human brain is able to manage.
And that's a good point. I think I was hoping to get through a single discussion in 2025 without mentioning AI, but it seems it's not fated to be. So,
well, yeah, we don't need to go into that. I've used it a lot.
Okay,
I've
let's talk about that.
experimented with it a great deal.
You have or you have not? You said
I have. No,
go
I
on.
mean, I just see it as it's another tool. I mean, I have always tried to use more sophisticated tools. To me, this is the whole progression
Yeah,
of computer science.
sure.
Is we try to raise our level of abstraction, and this is just another tool. And I know people freak out about it and everything, but and there are things. So my friend, I have a friend who's a science fiction writer, Paolo Bacigalupi. He wrote The Wind-Up Girl, and his latest book is called Navila, and he's working on the sequel to that. Anyway, Paulo, we went back and forth discussions about this, and he said, okay, I'm not going to use AI because that's not the experience I want when I'm writing a book. And I can't argue with that. It's like he has figured out what the experience he wants to have, and it is all of the process of writing the book. I have used it, like if you go to this, one of my many partially written books, and this one is called Thinking in Types. And if you go to thinkingin-types.com, you'll find it. Okay, now I've used AI wherever I can there because it helps me do research. It helps me do a lot of things. But ultimately, I have to rewrite its prose. It's not, it gets better at prose, but still, it doesn't understand passive voice. It doesn't understand a lot of things. It's too verbose and everything. So I have to rewrite it all. And it's like, but I have something to start with. I don't have to start from complete scratch. Okay, that's useful. But if I start talking about these design issues that we've been discussing, I don't see how it's going to help me with that. And maybe writing Thinking in Types, or I was working on a TypeScript book for experienced programmers who already knew a couple of languages, because that's what we're doing with the effect-oriented programming book. We're all in it. And using AI as much as I could. And yeah, it moves you forward. There's still the ultimate problem of how do you organize this into the best way to present it to people, et cetera. And it's what they've found in factories and things is that robots helping humans is kind of the optimal. I mean, at least there at least have been some studies where, like, when you're working on a home project or something, if you could just have the robot hand you the things that you just go, I need a screwdriver, and it just gives it. How much faster would you be able to do things? How many more projects would you do if you had that kind of assistance? And yeah, we still need to decide what we want to do. It's like the effect stuff. It can do more and more of the surrounding fiddly work for you, but you still have to go, oh, I want to talk to this machine and get this information and do that stuff with it. You just have to do less of it. It's less of a hassle. And I think, ultimately AI will do that. I can't remember the name of the economic observation that somebody made. Yes, you're right, Sahad. Definitely know more than one language. So this was back when coal was kind of expensive, and they figured out ways to make it cheaper. And the initial assumption was that, well, if it's cheaper, I still can't remember why they thought nobody would want to use it. I guess or fewer people would want to use it. But anyway, the economic law or rule or whatever is that when a resource gets cheaper, the demand goes up. And so the resource that we're talking about here is, I guess, the ability to create useful systems. And that has been really expensive for a
Yeah.
long time. And every time we make the system bigger and more comprehensive, it gets more expensive and we have all the organization problems. Okay, so what AI is doing is it's making the creation of those systems, well, at least in our narrow little field of computer science, it's making the creation of those systems cheaper. Now, do
Yeah.
you think we're going to now want less of those systems?
No, of
Or
course not.
you can look around and you can see, look at all these unsolved problems that are too expensive to solve right now, but are
Right.
becoming less expensive because you can have one programmer with an AI that would require a whole company to do.
Right. Right.
And so the demand is going to go up. I mean, the companies who are firing people willy-nilly, I think, are going to realize that they overdid it, and they're going to have some there will be some surprises for them.
Right.
But I mean, that's management again. You know, if the AIs were involved in these decisions, they would probably make different decisions. Because
I
I
reckon
mean,
so.
you know, you look at a company and you go, okay, what is a company? Well, a company is its people, and they will tell you that. They go, oh, we're a family, or the company is its people. But after years of somebody learning, you know, they becoming this really important resource
Yeah.
for that company, all of the knowledge that they have, and then the company goes, oh, well, you know, quarterly profits will look better if we throw this person overboard. It's like,
Mm.
well, I think a reasonable AI system is going to look at that and go, that's not gonna really work out in even the slightly longer term.
Right.
But if you're a CEO who has learned that quarterly profits are the only thing that matters, then you're gonna say, well, this is how this is the one lever that I have. We pull it, we throw people overboard, and then we can always hire more people later and bring them. But you look at the cost of bringing
Yeah.
somebody in and bringing up to speed. Anyway, I could go on about that
Sure.
for way
We
too
should,
long.
we should do that over some alcohol. But I think what I would take away from that is that the AI models give us quick access to perspectives that we might not otherwise. Is that true? Did I kind of?
Oh, well, I mean, that's my experience. My experience has been, well, in particular, when I'm trying to solve a thorny problem, I can quickly get to either, if I'm going to hit a wall, I can get to that wall faster.
Yeah. Yeah.
There's
Exactly.
a misunderstanding of what Occam's razor is because of
Right.
the movies, and every writer just looks at the previous movie as, oh, the simplest solution is always the correct one. That's what they come up with, and it's like, that is, why would you think that? Why
Yeah.
would you think that the simplest solution is actually going to be correct? But when you look at it, it's not a law that tells you the right answer. It's a strategy. It says, when you have several different ways to go,
Right.
try the simplest solution first. And if that works, great, you're
Right.
done. But if
Right.
it doesn't work, you've learned something in a short period of time that you can apply to the one that looks like the next most complicated solution. So
Right.
you're slow. So what it's doing is it's reducing the amount of time that it takes you to get to a solution. It's a strategy to get there. So in my experience, what AI will help me do is because if I spend a lot of time on a particular approach and I run into a wall, it's very possible that I go, I'm just going to give up because that was
Right.
so hard and I failed. I'm going to give up. With AI, I can go, oh, let's try this quick. Oh, it's not going to work. Let's go
Yeah.
back. Let's try a different approach. It allows me to implement Occam's razor more easily and discover what does and doesn't work. And I mean, I found it super useful for that. And
Right.
I wouldn't have solved those problems otherwise.
Wouldn't have even endeavored to. I see. Okay.
No.
So.
No. Yeah, it's like,
Yeah.
right. You've probably had that experience where you go, well, normally, this is gonna. I could optimize this little thing in my life. I could create maybe a little command line program or something.
Sure.
But it's like, it's going to be a bunch of work, and you're going to run into these issues, and it's just not worth the time.
Right.
Now with the AI, you can go make it work.
Why not?
Write
Well,
the tests and make it more elegant, make it more understandable. You can
Yeah.
go through that fast enough, and the whole process becomes delightful rather than a drudge. So,
So 100%. So for me, we've highlighted, we struck upon a few things here. One is
mhm,
that AI solves the tabula rasa problem, right?
mhm.
Nobody likes a blank canvas. It's just stressful,
I
right?
mean, it was fun at first, but
Well,
at this point, I'm not. Yeah, I'm tired of it. Yeah,
I'd
I
much rather
want
be at a
more.
place where I've got something to chew on and I can refactor and
Mhm.
rework and
Right.
revise and whatever.
Yeah.
It solves the maze running problem, which is to say I can try a bunch of possible routes through a problem space,
Mhm.
and you know,
Right.
I can try them out much more efficiently.
Yeah.
And for me, the other thing is going back to that, the team of CEOs. It gives me expertise in places that I wouldn't. So for example, I found that the average AI model for me as a person who's been doing Java and Spring and whatever for decades, literally decades now, and uh,
Mhm.
in that world, the models don't really help me. They're not going to do a better job because by definition, the corpus of code upon which they're trained is the internet, and the internet by definition doesn't have the latest and greatest
Mm.
or the best code. A lot of it's
Right.
just going to be sort of fair to middling or old or antiquated, whatever. So as an expert, I tend to produce better code in that particular domain than the AI models. But I don't know enough about React or 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 whatever. So the average quality of these other venues of
Yeah.
pursuit goes up, and so that's where it's useful for me is to
Yeah.
raise all those things up, a notch.
Mhm.
Speaking of raising, I wanted to thank you belatedly. Speaking of raising things up a notch or two, thank you for UV. That was a great suggestion last year.
Oh,
Oh, yeah,
yeah.
yeah. I
Oh, no, that's amazing. Yeah.
so good.
Yeah, those
Small
guys,
win.
Astro guys are doing incredible things. Yeah.
I I was a pip. I mean, even the command is more concise. Just UV instead of pip inv I was using before.
Oh, yes. Yes, it is. Um, can I ask you is it possible to pause this?
We can, yeah, we can.
Okay. Can we pause this?
We could wrap it up. We could pause. We could do whatever you want. I'm
Okay.
I'm I'm so grateful for you.
Let's pause it if you
Okay,
can.
sure.
Okay.
We're gonna. Do you want to just? What are you thinking? Like half an hour, 20 minutes, 5 seconds,
Um,
whatever you
I
want.
mean, it can be 10 minutes.
Okay.
Yeah.
Interregnum. I'll take us off screen,
Okay.
and people on the stream just hang out. We'll be back in whenever we get back.
10 minutes. Yeah. Okay.
Sure. Cheers. You back?
Yes, I
All
am.
right. So we yielded that thread for a few minutes,
Yes.
and good thing that we did. You ever have a conversation and then you leave the conversation, you see something, you think, oh, I wish I'd seen this before, I could have brought it up. That's what we just did. We left the conversation, but we yielded it. We didn't actually end the conversation. And so then as I picked up my phone to doom scroll, as I'm wont to do, I saw this great tweet from Debashish Ghosh, who's a you know his own level of virtuoso and genius in the language community. And he posted some hours ago about Rob Pike's rules on complexity. And it's from Notes on Programming in C. And he has rule number 5. It is data dominates. If you've chosen the right data structures and organized things well, the algorithms will almost always be self-evident. Data structures, not algorithms, are central to programming, which brings us back around to the idea that we were talking about earlier, types versus inheritance, right? Like I hadn't even thought about that. That's a great. And then, of course, the first response is, how can you be so right on this point and then make Go? Which is,
Yeah. Well, and I'm not sure. I don't know. Does data structures or algorithms? Why does one have to be? I'm not sure if I buy that. I would say, yeah, you have to have both.
yeah.
But why is one more important? I guess it depends on your perspective. I guess if you're talking about creating a program, maybe in some domains, a lot of what you're doing is creating data structures, and the algorithms might already be there. You just apply them to the data structures, but then there's other domains where maybe that's not true. So I don't know. The desire to have one superlative perfect solution is suspect
Yeah.
to me.
Well,
That's
he wasn't talking about abstract, deeply seated hierarchies of types in C, of course, but I do love that he understood that you should model the data and the rest will sort of in his
yeah,
mind.
it's certainly a reasonable place to start is data modeling.
It's amazing.
Yeah, yeah, and we seem to be getting better at that.
It's only taken all of computer science to get there.
Yes, yes. Well, it's like us in our lives. You learn a thing and you go, boy, that doesn't seem like it was a huge thing. And now that I see it, and
Yeah.
it's taken me my entire life to get to the point where I can see that. And yet, yeah, once you see it, you just go, really? It took this long to figure that thing out?
I'm not smart, and so for me it was a semicolon in English. Like it took me
How do you
years.
semicolon?
I mean, yeah, I mean, don't laugh, but it took me years to figure out.
No.
I thought either you had a period or you just kept talking. Why would you want? What is this soft period business?
Well, and there's many ways to pause. I mean, you've got commas and semicolons and
yeah.
em dashes,
Uh-huh.
and they all kind of have a different feel to them, and your own personal writing style.
Right.
I would use semicolons way too much,
Sure.
and em dashes and parens. There's another pause, and I realized, oh, I do this too much, and what I really need is shorter sentences. I need to
Right.
break things up into sentences. Don't fall into the trap of going, oh, I can make a giant sentence if I
Right.
put in all of these pauses in various forms. And I mean, I still do it sometimes, and that's part of writing style too. You have a bunch of short sentences, and sometimes a long sentence breaks that up.
Yeah.
And
But
it
if it's
makes
too
it
short,
flow better.
if there's too many short ones, it's monotonous. Like
Yeah, it
she's
can be. It
yeah.
can be. It's figuring out the balance of that. Yeah, it's no, it's part of how you develop your writing style.
Yeah. I'll never get there. And the worst part is I speak other languages and it's a totally different
Mhm.
game, there as well. So my brain will never. But I'm starting to the semicolon I'm starting to make progress on. As a person, actually, your friend Daniel Will Harris.
Yes.
I'm sure he would appreciate the mention of the M dash, which is the only correct dash to be using in the middle of a sentence, right? Right now you don't see people doing that correctly in the modern world. It's just a minus everywhere.
Oh, you mean instead of a hyphen?
Yeah.
Right, because a hyphenated word. But then there's also the N dash.
Yes.
Which I think I would have to go ask the AI where to use the N dash, because I'm really not sure.
I used to know.
Yeah.
Back when I was knee deep in Aldous PageMaker and Quark Express and all this kind of stuff in the 90s, but I don't know that whole world.
Yeah. There were things that I didn't learn until I had written numerous books, and there was this, I think it was Pearson, they decided to hire an editor who was actually a copy editor who really understood a bunch of things about English.
Yeah.
And we went over some of my stuff, and I, asked questions and learned a whole bunch of things I didn't know.
It's always good. English is a strange language, so the fact that we can communicate such highly detailed context in that language, it just blows my mind, because
it's adaptable.
Go for it.
The thing about it is that it's built in the idea that it can change, and so it does change things.
Is it the language, or is it us? Are we adaptable?
Well, you're asking I don't know, a nature versus nurture, or when you actually understand evolution, you realize, it's not just the creatures and the randomness of mixing together genes, it's also the environment, because you can mix together genes and you can come up with a perfect creature for the wrong environment that it's in, and it'll still die, because but in other things it can, if it's in the right environment, that and I think it's the same with when you look at language. You go, okay, the current culture that it's in, and the ability, if a language is so rigid that it can't change, that I think is reflected in the society that it's in. And societies that can't change do not ultimately.
Doesn't bode well for them. Yeah.
Doesn't benefit. It doesn't benefit enough people.
Yeah. Well, this gets us back to, I think, so we're talking about AI before the interregnum there, and is there such a thing as a programming language that was built for the benefit of AI? Like, to the extent that you and I are pontificating about all these design patterns and the optimal layout of our memory and our programs in terms of data structures versus algorithms versus whatever. Does it matter in 20 years or 30 years when the AI just refactors everything for us? Do we want it to be elegant for us or for it? Or is there such a thing as a happy middle ground? I mean, I haven't really. And by the way, also, can languages or technologies tomorrow ever hope to succeed if they haven't already got a million data points?
Right, a good point. Well, there are, let's see, it's Claude has come up with this thing called, what are they called? It's a way to teach it a subset of knowledge.
Yeah.
And that to me seems like it's got a lot of promise. Let me see if I can find what those things are called. Okay, so here's AI. ChatGPT.
These computers. Can't trust
I know. Skills, they're calling it. Okay, so you can, so there's that, and then I think there will be, especially because of the energy costs, there will be AIs that are specific to a particular topic. So, for example, we might see an AI that could run locally
Yeah.
that only knows about the TypeScript effect library. And that's going to make it a lot easier to use that library, and it's not going to cost a fortune. So I think what we'll end up seeing is it's like I'm going to ask a question, and the thing has to look at the entire world,
Right.
even though my question, I already know that it's just about programming, it's just using this language, it's just using this library. Why should it fire up the entire world to answer that question? And
It's
no wonder it's expensive.
a domain
So,
specific AI, like a domain
yeah.
specific language,
Hmm.
but a domain specific brain.
Or a domain
Oh,
specific LLM, I think, as
right.
long as we're, um, the topic of artificial general intelligence, we don't even know if that's a solvable thing. It seems
Yeah.
like we should create something, we should be able to create something that can incorporate new knowledge and
Yeah.
also test its existing knowledge. So because the way I think of it is as a science machine. So, science says it fits the data and it's predictive. That's
Yeah.
what we want with our AIs, well,
Yeah.
with our LLMs, and we get all pissed off if if it doesn't, if it gives us 11 fingers or whatever. Oh, the model is terrible.
Right.
Um, so what the model needs to do, I think what artificial general intelligence would be, is the model be able to say, oh, I'm not fitting the data. I need to do some experiments. I need to get new data
Right.
to so that I can improve my model, and it just gets more and more reliable.
Is I mean, they do that in the training, right? Isn't that what
Yeah,
back
but
propagation and all that kind of stuff is? Is like,
well, I'm not an expert on this, but my understanding is that each time you generate a model,
yeah,
it's fixed. It's the
once
way I
it's
think of it is
generated, yes.
it's a giant equation with a, trillions of terms, and you put data in and it plugs it into the equation and it produces results. Well, that equation is fixed and it
Right.
costs $100 million or whatever to generate a new equation, and then that's fixed, and you go, well, obviously this is not sustainable. We need to create something that, even if it's still an LLM, it is somehow able to incorporate it, to adjust its information on the fly, and then we
Yeah.
won't have to generate these new things
Hmm.
every now and then.
Well,
It's too expensive.
that's gonna be. I don't know.
But we'll
I'll have to
use
watch.
LLMs to be able to help us. LLMs and the new, the what is it? The quantum computers that they've had a bunch of breakthroughs with
Yeah.
lately. We'll use those things. That's one of the things that bugs me about science fiction, is that it usually says, well, let's just imagine that we can do interstellar travel.
Uh.
And but
Sure.
but
But
everything else
how?
will be the same. We'll have a feudal system who has interstellar, and you go, nothing fits with our experience there.
Right.
As we move our technology forward, our culture is affected by that, and also other technologies are affected,
Yeah.
and it has this combinatorial effect. And so you can't, the imaginations of the future that we get from science fiction is like, you go, really? Could you work a little harder to try and imagine all of the rippling effects from all of these things, and how they, just bounce back and forth and reinforce each other and make changes?
I mean, if we had interstellar travel, that would imply the ability to create energy efficiently, and that implies superconductivity or something better, perpetual energy or something, and so that would, like, the real problem is scarcity of resources, right? And so to the extent that we
Well,
someday
no,
solve that, you know,
to be able to have reasonable interstellar travel, we need to have be able to massively accelerate things, or figure out how to jump them through wormholes or something like that. But
right? Well,
even within a solar system, to be able to travel one place to another in a reasonable amount of time, the acceleration that you need to means that you need to have control over inertia, and
Sure.
you need to have gravity, and it's like, oh, so there's a lot of things where it's like, no, we're just walking around to the floor of the ship.
Sure.
We don't even talk about how we fix gravity. But if we want to go down to a planet, oh, we have to get into this shuttle and use chemical
Right.
reaction rockets. And it's like, well, you figured out gravity. You could just move yourself down. You don't. It's
Yeah.
like an elevator now. You don't have to
Right.
do. But they don't, they don't think about that. They
Of
just
course
go,
not.
well, the last guy just did this, so I'm going to do the same thing that they did. And we don't have to explain that we figured out gravity and inertia, because to accelerate at those rates, you would basically turn anything organic into a thin film on the back of the spaceship.
Right.
So you have to control those things, and we don't know how to do that yet.
Well, that's what I'm saying. Well, I mean, let's just suppose that all things stayed the same, and but somehow we found a way with a V8 billion Chevy Cadillac or whatever, the V8 billion engine, but everything else is the same somehow, and we haven't figured out perpetual energy, and we haven't figured out to fix the
We're going to put
scarcity issue.
gas in this thing then?
Yeah, it needs
Okay.
a small sun's worth of gas, but yeah, it'll be fine. So I guess what I'm trying to say is, in that world where that is true, you would still have, there's the equations that make it sort of, people are constantly trying to figure out this modus vivendi, like they're trying to I guess, okay, you'd probably have drug runners, you know what I'm saying? You'd probably have people doing terrible things across intergalactic lines now, because nothing would change. But the real thing that would change everything is if you had the ability to actually solve the scarcity problem, right? So if we had, like right now on Earth, I'm talking about AI, we've got people spinning up these nuclear reactors. Like, that's insane. That's to me, that just blows my mind. We're in a.
Yeah, are you talking about fission or fusion?
I don't know what I mean.
Well, there's some, I don't know where it is, but there's some, experiments that maybe we're close to fusion.
But I mean, right now they've got nuclear reactors, like actual nuclear reactors that were decommissioned. They're bringing them
Oh, you
back
mean to
online.
drive the AIs, right?
Yeah,
Sure.
and I'm just thinking, well, oh my goodness, we're this is a very surreal thing. If you told our ancestors 50 years ago, we're going to bring these monsters that have small stars in them back online just so we can power people's ChatGPT conversations. I don't know. It would. So
it's a little weird. Those, I mean, the earlier nuclear reactors were built before we really had the proper technology. I think we wouldn't have had these, the meltdowns that we did if we had mostly better computing systems.
Yeah.
To watch, because it relied on humans to
Right.
watch these things, and it relied on industrial age management and all these things. That I think the real problem to solve is, well, I heard someone say that, I don't know, there's some estimate of 1 out of 10 people is a dark triad type.
What's a dark triad?
Dark triad is narcissist. What's the other one? Psychopath, or and this is the one that I don't understand, which is Machiavellian. I mean, he was a philosopher and he had some ideas, so I'm not sure what particular ideas they're referring to, but basically someone who is kind of dangerous.
Yeah.
And our current systems seem like they've been designed by those people so that those people can be in positions of power. Okay. And that, I think, causes, I mean, the other 9 of us want to live our lives in peace and do interesting, creative stuff. Okay. And then 1 out of 10 is just needs to cause havoc. And to me, that's the problem we need to solve. And we had somebody come on from Ukraine, and they're dealing with one of these people. they're struggling. My God, my heart goes out to those folks.
Yeah.
To imagine having to live through that it's like, I don't want to, they don't want to, they want to
No,
live in peace, and
surely.
they're forced to do all this stuff to keep their anyway.
Yeah.
So to me, that's where we look at hierarchies, we look at corporations are still, they're basically feudal systems.
Okay. Good point. I didn't
They're
think about it like that.
yeah. Oh, I mean, when you look at them, you you see all the echoes of feudalism there, and it's like coming up with a system that is better is going to require, what can we give these people to do that they won't cause this kind of havoc? They still need something to do, but we just need to sideline them over here so that the rest of us can move forward and get stuff
Right.
done, and they can work out their things that they need to work out without
Well,
causing.
isn't that kind of what, actually, speaking of the team of CEOs, I thought Germany had like this thing where like companies have representatives, like there's a board or whatever, but it's like people from the company. It's not just the higher ups, it's everybody, from the janitor on up. They have representatives in the council or whatever that runs the
So
company,
there can be feedback because
tempering the worst instincts from any one person,
because in a hierarchy, you like, ideally a leader has some sort of responsibility and
Sure.
serves the people that they are leading, but the forces are always, well, the person above them has
The
power, existential power over them.
Sure.
So the connection that they have with the people that they're leading is, I mean, call it an emotional connection.
Yeah.
But ultimately, okay, if it makes you mad, maybe the leader is going to be a little less happy or whatever, but it's not like they're losing their job or they're losing their power or whatever it is. So because we have these power hierarchies, we end up with, and the person who is most interested in power tends to climb those hierarchies. And so we end up with, not always, very often, very suboptimal. And you can say, well, they're maximizing quarterly profits, but I would say there are ways that an organization is going to do far better than having a psychopath running them. They're going to thrive much more. They're going to benefit not only the people within them, but their customers and their shareholders and everything.
Yeah.
But the human brain just is, and the structure is just not set up to optimize that.
I see.
Yeah. Well, anyway, and that's just, we're off into philosophy here. So.
I know. We kind of have to, right? With the AI stuff these days, it really is you've got a piece of software that has, for lack of a better word, agency now, and it can, the question then is just how many levers of control do we give it? And I think right now we're in a race to see how open. Giving it run of your computer is one thing, right? But giving it run of your
civilization,
health, finances, civilization. I don't know. We're not there yet, hopefully.
No.
But it's no doubt we're going to go just a little too far, and we're going to the pendulum will have to swing back a little bit. Such is life, Hopefully we don't do anything silly in the meantime.
Ideally, the AI systems will be agents to keep us from doing they will help us do less silly things than humans. I mean, that's one of the things that people panic about. They go, oh no, what if it wants to take over the world? Well, how many humans have we had in history? And that was their very goal, and they were ruthless.
Well, I mean, and that's a good
people that they murdered,
to the
starved, or whatever.
To the extent that,
like, yeah, I think a machine can do better than that now.
I hope
but
so.
People are going, oh, but we want a human. Do you? I don't know. Humans have not had this great track record so far in figuring out.
Well, that's just it. These AIs are sort of informed by corpus of knowledge from humans. So it's sort of a
their knowledge base is not great now, but the idea of making them into science machines
yes,
is I think, I mean, because ultimately they're not going to be useful if they're not giving us useful results, and if they're not science machines, they're not going to give us useful results.
right. That's a good point. So it sounds like you're an optimist here, or at least a pragmatist. You know, I'm not a pessimist. I see, to me, the AI, like I said, it solves these big three problems that I confront every day. One is, which is give me visibility into other positions and perspectives. Two is help me solve the tabula rasa problem. And then three is, make me an expert in things I'm not an expert in, right? And that's useful. There's no doubt about it. I don't.
Oh, yeah.
And just sort of like the effects that we talked about earlier. There's all the stuff that needs to get handled, and I much prefer to offload that to the machine, and I can express those as effects. And to the extent possible that I can, I want to express these things that I need to care about in building software, and I can just ask the machine to do that. I can ask the AI to do that now, and it's an interesting time to live. It's just a matter of the gradation, I think.
Yep. It helps you. It's a tool that helps us solve problems, and it's very early days, so it's an imperfect tool, but even in its current state,
right, it's amazing.
Really amazing. And there are people, like, if you look at material science, how chemists and material scientists have to find a new material. They go, oh, we want it to have these characteristics. Well, they have to just wade through all these different possibilities. An AI, large language models, they're doing it now. They're able to narrow it down. Well, here are the three most possible, and you should try this one first. And it's like, that's huge. And we're discovering new things and new approaches. And, so the upside is massive.
Yeah.
And of course, because humans are involved, they can manipulate it to do nefarious things.
Oh, well, okay.
But
ultimately,
and that's what people are afraid of. And yes, but they're afraid of the machine and not the human, and they should be afraid of the human. That's the real problem.
There you go.
Is the way humans work, and we that's what we need to focus on. How do we ask the AI to solve the human, the dark triad problem, basically?
Right. Yeah. Oh dear. I mean, as soon as the AI introduces a language that looks like PHP, I'll know it's gone too far and it needs to be disabled. So that's
yes. But I think the language that we end up with might be, I don't know, what language would the AI design to help us communicate better with? I mean, because we're raising the level of abstraction from programming languages to how do we interact with the AI to solve our problem, and it might come up with a better way for the humans to structure their questions.
Oh yeah.
And that would be our new programming language.
Wouldn't that be just the ultimate kicker? What if the AI actually gave us the ultimate programming language? What if you like you were talking about earlier, like we kicked off the show with, what if we did actually get the one true programming language somehow, but it came from some iteration with an AI? Huh.
I would think that would be more likely than humans just saying, oh, well, now we have effects, let's incorporate those into our language. The AI is probably going to be more capable of saying, well, what problem are we really trying to solve here? And how do we create a language that allows us to, or maybe it's already English and it's just the way that we structure or whatever language you speak. And it's here's how to structure the problem proposal, the problem, how you pose the problem to the machine. And if you think about it, I mean, I don't know about you, but I found my thinking about how do we describe a problem to be improving, because I have to think about how do I ask this problem in such a way that the AI knows how to solve it.
Right. And the prompt engineering is to that. That's an art form. Hopefully, whatever language it is less sensitive than both English and JavaScript to the placement of semicolons, uh, whatever that is. That's a good point. Interesting. I don't know. You've got me there. That I don't know what's going to be the uniform interface, but it's exciting to think about.
Yes.
You think you'd ever write a book on AI?
I have not. I mean, I've been drawn to AI as a user, and have thought about how do I think about what this thing is doing.
Yeah.
But boy, I don't know. I'm less interested now in implementation details than I have in the past. I'm more
Sure.
interested now in higher level questions.
Sure.
And so I don't it's not calling to me right now. What is calling to me is maybe some of the things that we've talked about here. How do you think about architecture and design and
Yeah.
just general problem solving? How do you think about how we solve problems? And let's look at some of the rabbit holes that we've gone down and why they haven't panned out.
Right.
So yeah, a lot of the topics that we've touched on here.
Okay.
So
Are
yeah.
you, as we wind down here, are you sort of, do you have any projects you can tell us about, or anything we should, besides the TypeScript effects-oriented programming? Anything else we can look
Well,
for?
there's the TypeScript effect-oriented programming. You can look at the thinkingintypes.com, which is available
Ooh.
online. But that, who knows? I mean, that was a book where I was going, I guess I haven't heard enough feedback yet from that book. I gave a little presentation at the Python conference and in the typing summit, and there was a lot of interest. And it's in a form which is somewhat usable at this point. Yes.
Oh.
Yeah, so you can see it.
Oh my
But
goodness.
I am not sure what I'm going to do with that. There was the let's see if I can find the other the TypeScript book that I was. Let's see, go to my GitHub account.
Look at that. I'll just, you've got this whole, I mean, this is a lot of work here, Bruce. You should.
Isn't it?
Yeah.
Yeah.
Wow.
Well, here's a disturbing thing that I figured out. I think I told you I probably have as many unfinished books at least
Right.
that as I do finished books. Oh, yeah.
Wow.
There's like a disturbing number of them.
That's an amazing thing. Well, that's how I
Yeah.
found your Thinking Enterprise Java book. You had that up there for people to look at 25 years ago, 20 years ago, whatever it was.
Right.
And for a
Yeah.
minute there, you had older editions of Thinking in Java, I remember.
Where the heck is that thing? Okay, because I was doing.
Huh.
Well, okay, maybe I'm trying to figure out how to find this TypeScript. No, that can't be right. Maybe I haven't made it public yet.
I mean, wow.
Well, anyway, I was working. So, yeah. Anyway, there's these various projects, and at this point, who knows what I'll do with that? Because I'm more drawn to this. I don't know, design ideas about software than maybe a specific thing. But anyway, it's in a state, it's on GitHub, the source is in Markdown, so maybe people will want to contribute to that somehow. I don't know. A few months ago, I was painting my stairs using an airless sprayer, which is a really interesting tool. And for some reason, when I finished that project, I kind of lost interest in a lot of things.
What?
Yeah, it's a very, is this a correlation, causation? I don't know, but it's not complete. I'm still interested in thinking about, like, when we work on the book,
Right.
the effect-oriented programming for the effect library. When we're working on that, I'm engaged, curious about it, but it's just all, I guess, at a higher level.
Right.
So that's all I can think of. I've been painting for 20 years or more,
Like evil
abstract
and yeah.
painting, and that's been engaging me lately. But I'll come back, I think. But for a while, I was going, have I just completely lost interest in all of this? And the answer is no. But I just think it's at a higher level
Sure.
that I'm thinking, and so maybe something will come out of that.
Well, can
But I
I?
don't want to. Yes.
Did you that thinking in the concurrency in Python book? Is
Yeah.
that in a place where people could look at it?
Let's see. Let me look.
What I would say is, I think you know about LeanPub and
Yeah,
this
sure. No, I
this
use LeanPub.
yeah. So this
Mhm.
Python thinking in types book, why not put it out there? You could make a little
Well, it
money.
is out there.
I mean, get
It's
it. I mean, it's out there for. I mean, but I'm saying is get it on LeanPub, sell it, and get people feeding back to it.
well,
Use
because
that
it's
content.
not really
It's really
finished.
good,
It's not really finished enough to, or at
even for
least it's not
the
up to my standards. And people can use it now. You know, they can use it now. I know I could put it on LeanPub. They told me, well, if if you don't want to sell it, you can put it up there for free, or
yeah.
and people can. But I don't know. I don't feel that good about putting something up that is not up to my sense of quality. I guess I'm okay with the way it is right now, but I'm
As
looking for the
you do
what
that,
we
as one
call.
of your fans, though, I think
Uh-huh.
uh, people would love to. Even your bad drafts are still better than what most of us get to read. So this is
Yeah.
cool, and the same thing for your Python, your concurrency in Python one. Just
Okay. Where
getting
did
them
I?
out there and getting people galvanized about it. I'm sure they'd be very happy to feedback and whatever
Yeah.
if they wanted
Yeah,
to buy a copy.
but then that implies that I'm gonna, continue to work on it. I'm not sure that I
Well,
will.
no, that's okay. You can say that. And
Here it is. I think it's
pasting types. This is really great. I can't
concurrent
believe it.
Python. Here we go. No, that's public. Okay. Let's see. What state is that in? Okay. Yeah, so I will give you the link,
Yeah, this is so good.
and let's see. So I will put this up to you.
There it is.
So
Look at that.
that's the link to that, and I mean, you can put
I
that up
can
if you want.
share that.
Sure, it's public. It's on my GitHub repo. It's public. That one is not. I think that one is that one have a LeanPub version or something. I don't know where
It
that
looks
one
like
is.
it's 9 years old, so it's gonna be.
Is it
Uh,
that long? Oh my gosh. Well, the last time I worked on the chapters was 7 years ago.
it's
Um,
using Pandoc flavored Markdown. My goodness.
Pandoc flavored Markdown. So, which needs to be. Oh yeah, and there's not even that much there. Was that the most recent? Yeah, I don't know. There's. Oh, maybe. Yeah, I didn't. Yeah, I see that one. I didn't get that far with that. Let's see if I've got another. I also had one called, maybe it's this one. It was
This is so
clarifying
cool.
concurrency. Where did it go? Concurrent Python concurrency for the confused. That was private. Oh, clarifying concurrency. Maybe that was it.
Huh.
Oh yeah. Okay. Maybe this one is better. Oh no.
Okay.
I
Same.
abandoned that project too. Well, but I can give you the link to
Sure.
that, and those chapters are. But there's a thing that explains why I quit that one. Okay, so here's another one. I know.
This is so
There's
good.
the the number of books that I have started and then abandoned is surprising to me because
This
it
is.
goes way back, as you said. Yeah. So,
It's not even
but the
Christmas
thing
yet.
is, I ran into a wall about, and I feel like at some point I'll probably realize, oh yeah, that was right. I ran into that wall for a good reason, and I stopped for a good reason. But yeah, for a while I was writing a lot about it, and then it just didn't. But that's okay. That's what you learn with abstract painting too. You go, here's a thing I can try, I can work on, and
Right.
it goes for a while, and then it peters out for some reason. But in the meantime, you've learned a bunch, and I learned a lot more about concurrency in the process.
Yeah.
And maybe that feeds into, okay, this is why effect systems are better. And the other thing, because it solves a problem that maybe the human brain, well, a lot of these concurrency systems just don't scale either.
right.
So there's another link I want to give you, which is this one here.
I'm taking these links that you're sending me and I'm putting them in the notes for YouTube.
Yeah.
Right now. As
So
we go.
this is the first week of March up in Crested Butte, Colorado, and this used to be the Java Posse Roundup, but then the Java Posse finished, and so we turned it into the Winter Tech Forum, the WTF we call it, and that's actually a good fit. And if you go there, you'll see this will be the first week of March this year, and it's up here in Crested Butte. And this is an open spaces conference, so we don't have lecturers. It's all about creating discussions and interactions, because you're traveling all the way up here to Crested Butte, and so it should be all about experiences and not listening to lectures that you could listen to on YouTube. So yeah. And I'm surprised you haven't been up, because James would have told you about this.
Oh yeah, and even the Java Posse folks invited me at some point. I mean, it's just I'd love to. Yeah, I actually now more than ever I have more time and more means by which to get myself there.
Yeah, because I think you would enjoy it. This is a totally different experience than you get from any other conference, because it's not about speakers. It's about discussions.
Which would be great for me, because anytime I can not do work, I'm a big fan. I don't know if I've told this to you, but I'm a fan of not doing work.
Well, this is my experience organizing the conference, is that once you get it going, then everybody takes over and runs the they do it for you. I have to explain things at the beginning, but even then, all the people who keep coming back are resources to explain how things work and guide the process and everything, because it's an amazing experience. And we have lightning talks, we have a hack day, we have a progressive dinner, we have a banquet, we have stuff going on all the time. So it's not like, when you usually go to conferences, you go, okay, I went to a talk, maybe I've had some hallway conversations, but what do I do with myself now? Well, we take care of all that. You can do stuff from the moment you wake up to the moment you fall into bed, including game nights. And it's what you want if you go to the trouble of traveling to a thing. You want an experience all the time. So
that's amazing.
So, yeah.
I did the JCrete one.
Right.
Dr. Kaboots.
Yes, Heinz.
Yeah. Yeah. And I love that one. I mean, I love conferences. I have no reason not to go. It's just been a matter of scheduling. And then there's that pesky pandemic and blah, blah, blah. Okay. Let me see. Maybe this is the year. You've shamed me enough.
Yeah. No, you should come. I mean, James is usually able to be here, and Bill lives here, and then we got a bunch of people who come up regularly. So yeah, and now we're incorporating students from the university.
Even better.
That that brings a lot of good energy, and it's very satisfying. So, and some of the professors come too. So it's quite an experience.
You, sir, are amazing. Thank you very, very much.
Yes, it's been great. Thank you for all the stimulating questions and discussion.
Well, the highest praise I've ever gotten, highest compliment I've ever gotten. Thank you. Thanks for hanging out, everybody. Who I'm sure people were just like, if I were in a car listening to this discussion or something, and I got home, I'd just pull over before I got home to continue listening. This has been so much fun talking to you.
Yes, I admire anyone who makes it to the end.
Well, So, okay, with that, have a wonderful day, everybody. Be
All
good
right.
to each other. Bye.
Thank you.